China, the largest military bionic robot yak has been created. It is intended to be used as a courier for delivering ammunition and supplies, as well as for reconnaissance missions. The Chinese-engineered mechanical yak is enormous, powerful, intelligent, and fast. The state-owned China Central Television presented this robot to the public. While its robotic counterpart is less than half its size, it can carry up to 160 kilograms of cargo and achieve a speed of 10 kilometers per hour. This model is originally designed for military tasks, capable of navigating through any terrain, including snow, deserts, and rocky terrain. The robot can jump, run, move diagonally, and make turns. In addition to advanced sensors, it is equipped with 12 sets of modules that allow the machine to perceive the surrounding world. The bionic robot can gather tactical information on the battlefield and be utilized for logistical tasks. The Yak robot is expected to become a strategic tool for conducting operations in the most challenging and inaccessible areas and under any weather conditions, including deployment in border territories. In front of you is the Russian humanoid robot Fyodor, who can shoot with 2 hands. Developed by Russian specialists, Fyodor, final experimental demonstration object research, is designed for extreme situations and space exploration. The robot can operate autonomously or be controlled by an operator using a specialized control suit. The robot is intended to perform 2 main tasks: rescue people in extreme conditions, such as from collapsed buildings, and undertake space missions. Recently, it was revealed that Fyodor faced sanctions after it was discovered that the robot can not only shoot, but also shoot with both hands. Upon learning this, foreign companies ceased supplying components including gears, sensors, engines, cameras, and computers. Nevertheless, Fyodor continues to evolve, with the robot's developers transitioning to domestic alternatives. Work on the robot began in 2014, and it was first presented to the public in 2016. According to its specifications, the robot can already use a key to open doors, operate a fire extinguisher, and use a saw. In addition, Fyodor can drive a car and even crawl on all 4s. Furthermore, the robot has mastered doing both transverse and longitudinal splits, setting a world record. The robot stands at a height of 180 centimeters and weighs between 105 and 106 kilograms. The EOD robot is a specialized device designed to support operations related to defusing explosive devices. This high-tech device is equipped with advanced technologies such as cameras, sensors, and explosive detection systems, enabling it to safely detect, locate, and neutralize explosive devices. The robot is actively used by the Chinese military, enhancing the safety of military personnel during operations involving the handling of explosive materials. An important asset in China's arsenal, this robot significantly reduces the risks associated with military operations, providing reliable protection for both military personnel and civilians. As a testament to its significance, the robot remains an indispensable tool in the Chinese military's strategic assets, underscoring its commitment to minimizing potential risks and saving lives during complex operations. These robots can be quickly deployed from bomb disposal vehicles and can provide operators with a first-person view of the mission via real-time video feeds relayed back to the EOD vehicle. This robot from Google is not as well known to the general public as Atlas or Optimus from Tesla, but it has been recognized as one of the best in the world. Shaft, an android robot created by Shaft Inc., a Japanese company owned by Google, became famous after reaching the finals of the DARPA Robotics Challenge, a humanoid robot competition. During the competition, the robots had to perform 8 tasks: to drive a car, bypass rubble obstacles, clear a doorway from a pile of debris, climb a ladder, open doors, build a passage in a plasterboard wall using tools, close pipe valves, and find and connect hoses. The Shaft robot performed best on all tasks, scoring a total of 27 points out of a possible 32. It weighs 95 kilograms and stands 1 meter 48 centimeters tall. The robot's agility allows it to reproduce almost all the movements available to humans. At the end of the DARPA Robotics Challenge, 8 teams of designers reached the finals. All of them received a prize of $1 million. The DARPA project is directly linked to the US Department of Defense, so in fact we can say that this robot was originally created for the military needs of the US Army. The U.S. Army Research Laboratory has initiated collaboration with Army engineers and several industrial enterprises. The ultimate outcome of this partnership is expected to be a line of autonomous mini-robots designed for use in urban environments, mountains, and caves. One such robot, potentially, is an autonomous reconnaissance spider robot. This mini-scout will be equipped with various sensors for autonomous navigation and obstacle traversal, along with standard and thermal cameras. Robotic reconnaissance platforms will enable gathering information in conditions that are potentially lethal for humans. The U.S. Army continues to expand its humanoid workforce. A new addition to the ranks is the Petman robot, which will initially be used for testing uniforms, protective suits, and other means of sustaining the viability of military personnel. However, the creators note that after some enhancements, the robot may be capable of actively participating in combat on the side of the US Army. Petman is a unique invention, matching average human dimensions precisely. It has the same 4 limbs, but no head, replaced by a red flashing beacon. The android can move at varying speeds, jump, squat, perform push-ups, and maintain balance even under external influence. Its physiology also mimics human characteristics, at least to the extent necessary for testing military wardrobe items in real conditions with the maximum possible level of realism for the machine. The development involved the expertise of the top professionals from Boston Dynamics, closely collaborating with the Pentagon. The company refrains from commenting on whether their creations can engage in combat against humans and wield weapons. What is known is that the current version is definitely incapable of such actions, unlike potential future developments. Specialists from IHMC Robotics and Boardwalk Robotics have joined forces to create a robot named Nadia, who, judging by the published video, is already improving its boxing skills. It is designed to perform tasks in places dangerous for humans, such as participating in rescue missions or space exploration. According to developers, Nadia is currently one of the most complex humanoid robots in terms of design. With 29 joints in its body, it can perform a wide range of different movements. Such a sophisticated mechanism is designed so that the operator controlling the robot does not have to think about how to use the manipulators correctly, but acts intuitively. Yes, Nadia cannot work independently yet. So, according to its creators, there is no need to fear a machine uprising. IHMC Robotics hopes that their development will become a prototype for future robots and may also be useful for military purposes. The company explained that in complex situations, humans act much faster, so it is better to entrust robot control to them rather than artificial intelligence algorithms. Pentagon specialists closely monitor this development, and it is quite possible that in the near future, the robot Nadia will become part of American military programs and join the ranks of the US Army's military robots. Russia plans to create an avatar robot within the next 10 years, with the potential to replace soldiers on the battlefield. The robot can be designed in an anthropomorphic or non-anthropomorphic form, resembling or significantly differing from a human. In the latter case, the operator would feel, for instance, a leg functioning as a caterpillar track. According to the developers, the robot should possess functional capabilities comparable to humans. The goal is to create a machine capable of independently interacting effectively within human infrastructure, traversing rough terrain, providing first aid, and operating a vehicle. In 2015, the first developments of a humanoid robot capable of shooting and driving vehicles were introduced. A manipulator arm, controlled by an operator nearby, is used for firing. In the future, such avatar robots could potentially replace live soldiers. However, it is more likely that other countries, such as the United States or China, will be the first to implement such groundbreaking technologies globally, rather than Russia. In Korea, the first humanoid robot pilot in the world has been created, capable of operating any human transportation. Specialists from the Korea Advanced Institute of Science and Technology unveiled the world's first humanoid robot pilot. What sets the Paibo robot apart from other similar projects is its replication of the human body, allowing it to sit in the seat of any human transportation without modification. The robot can pilot planes and cars and cabins and seats designed for humans. This promises to expedite transportation automation across various sectors in the simplest way possible. For the military, such a robot would be a real breakthrough if placed in a combat fighter, thanks to its built-in artificial intelligence system, revolutionizing the military sector and creating the ideal soldier robot. The robot can react faster to emergency situations, retain all navigation maps and instructions, and remain unfazed in complex physical environments, such as encountering air pockets and potholes on the road. Additionally, the robot will gain experience through artificial intelligence. The robot's capabilities were tested on a flight simulator, performing taxiing, takeoff, cruising, maneuvers, and landing. In the near future, the development team intends to test the robot on a real light aircraft. The developers plan to complete the research project by 2026 and then proceed with the commercialization of PaiBot. Africa also has something to surprise the global defense industry. The Technological Center of Advanced Development's Katanka, a subsidiary of the Katanka Group, has introduced its latest creations, an armored vehicle and unique combat exoskeletons. Despite their somewhat clumsy appearance and almost complete lack of smooth lines, the Katanka exoskeletons not only protect the shooter's body, but also allow firing without touching the weapon with their hands. However, for these purposes, special drives are installed on the soldiers' backs, to which an automatic rifle is attached. At least that's what the developers claim, and the fact that soldiers and exoskeletons move very slowly is probably due to these being the very first versions of the device that haven't been refined yet, hence the angular appearance of the development. Kuratas is the first genuinely combat-ready robot in Japan. It is a robotic exoskeleton standing about 4 meters tall, running on diesel, and is offered at a price of $1.35 million. It was first demonstrated in 2012. The inventors of the robot decided to turn their dream into reality by establishing the company Suitobashi Heavy Industry and creating their first product, the Kuratas robot. This project proved to be so impressive that it attracted serious interest from the Japanese military. Currently in its present form, it may not be suitable for the Japanese military due to its limited maneuverability, delivery issues, and the robot's off-road capabilities. However, with appropriate upgrades, the first deployment of combat robots might become a reality in the near future. At present, the robot is equipped with 2 rocket launchers and 2 rotary machine guns. The machine guns can fire 6,000 rounds per minute. It moves on wheels at a speed of 5 miles per hour, approximately 8 kilometers per hour, for the civilian version, while the military version can move twice as fast. The driver controls the mechanism from inside the cockpit using a touchscreen and 2 joysticks responsible for the movements of Kuratas' arms. Additionally, Kuratas can be controlled remotely, not just from the cockpit. In Russia, a student from the Faculty of Control Systems and Robotics at ITMO University, Alexei Ledyukov, has created an exoskeleton capable of lifting up to 80 kilograms in the future. Despite its lifting capacity, the suit itself is quite lightweight, allowing for active movement and even running. Russian military has already expressed interest in this development, and testing is underway at military training grounds. The primary frame of the exoskeleton is made of carbon fiber, aluminum, and steel pistons, with all other components 3D printed. This exoskeleton offers numerous advantages, including mobility, compact dimensions, and importantly, cost. Comparable robots of this kind typically cost about $110,000, while the production cost of this exoskeleton is approximately 6 times lower. The developers plan to introduce a new, more technologically advanced version of the exoskeleton later this year. The upgraded model will be significantly lighter while maintaining strength. Here is a development from the South Korean company Hankook Mirai Technology, specializing in robotics, called Method 2. The Method 2 robot mech weighs around 1.5 tons with a height of almost 4 meters. Each arm has a mass of 130 kilograms. The company claims to have spent about $200 million on creating this robot. Method 2 was developed with the involvement of Hollywood visual effects specialist Vitaly Bulgarov, known for his work on robots for movies like Transformers, RoboCop, and Terminator. The developers state that Method 2 is designed to work in hazardous conditions where humans cannot be present without protection. In the future, such robots could be used in manufacturing, loading and unloading operations, and military missions. Millions of people have seen similar robots in science fiction movies. Work on the robot is not yet complete, and the creators still need to address various challenges related to its balance and power systems. In early November 2022, at an aviation and aerospace development exhibition in China, a Chinese manufacturer unveiled a robotic combat dog equipped with an automatic gun on its back. Mounting an automatic gun on a Chinese robot poses a serious technical challenge due to the weight of the weapon and the recoil effect during firing. However, the People's Liberation Army of China continues to show significant interest in using this type of military technology with heavier weaponry, capable of performing combat tasks through remote control or in fully autonomous mode. According to the Chinese news outlet Xinhua, China's military robot industry is notably benefiting from the current global tensions. Considering China's leadership goals to complete the technical modernization of the armed forces by 2035, transforming them into a technologically advanced army, the Chinese defense industry is entering a new period of rapid development. It is claimed that the robot carries a 14-kilogram gun and is controlled through an application on a military tablet. Additionally, it features built-in cameras with a 360 degrees field of view. This robot is designed to carry out tasks either in fully autonomous mode or through remote control. However, detailed technical specifications of the development are not disclosed. The Japan Ground Self-Defense Force Acquisition Technology and Logistics Agency unveiled a research prototype named High Mobility Powered Exoskeleton. This Japanese military exoskeleton is a device powered from the hips and knees with a remote wireless interface. It is reported that this wearable robot can reduce the perceived weight by up to 30 kilograms. For example, a total load of 50 kilograms would feel like carrying only 20 kilograms. To achieve this, the wearable frame extends to the ground, although apparently, there is no drive in the shin except for a passive mechanism. Interestingly, the prototype reportedly reaches a walking speed of 4 kilometers per hour and a running speed of 13.5 kilometers per hour, making it one of the fastest exoskeletons in the world. For US residents, this is a walking speed of 2.5 miles per hour and a running speed of 8.3 miles per hour. A tablet is used to adjust the control parameters of the wearable robot. The military exoskeleton prototype is powered by 4 batteries located on the user's back, providing 2 hours of operation at a normal walking pace. Megabots company has created the giant combat robot Eagle Prime, which will represent the United States in duels between similar machines. While initially developed as an entertainment project, the US military took notice of this creation, and it is possible that such advanced robots may be adopted by the US Army in the future. This 12-ton robot, standing at a height of 5 meters, is propelled by a tracked platform. It is equipped with a 6.2-liter V8 LS3 gasoline engine with 430 horsepower, a cannon, and a claw. The robot will be operated by 2 operators who demonstrated its skills on a small obstacle course. The project cost amounted to $2.3 million. The Russian state corporation Rostec has unveiled an unusual protective suit capable of withstanding even explosive ammunition blasts. Wearing such a suit, it is not frightening to walk through a mined field, and this is not just a hypothesis. Viktoria Kolesnikova, a member of the testing group at the Central Scientific Research Institute of Mechanical Engineering, walked through a mined area on a range amidst explosions and fire, resembling the Terminator, and emerged unharmed and alive. During a thorough medical examination after the experiment, no injuries were detected in the employee, except for a bit of dirt. Unfortunately, it was not possible to determine the explosive power this development can withstand, and the information might be classified. The blast-resistant suit developed by Rostec is expected to be adopted by the Russian Ministry of Defense soon. One of the most significant military developments in robotics is the American remotely controlled tracked robot for military purposes, the T-360 M2 MUT, which essentially serves as a multifunctional tactical vehicle with a hybrid drive. The machine is produced in 2 versions, wheeled and tracked. After a series of successful tests, the robot was adopted by the United States Marine Corps. The robot's platform is versatile and can be equipped with several types of machine guns or a 60mm mortar. It can also serve as an unarmed transport version, which, in addition to transporting equipment, can be used for evacuating wounded from the battlefield, reconnaissance, or launching drones. The robot's payload capacity is 433 kilograms. Its autonomous operation time reaches 72 hours, and during this time, it can cover over 100 kilometers. The humanoid robot DRC Hubo is also directly related to the DARPA project, and thus to the US Army. DRC Hubo also became known for its participation in the competition organized by the Pentagon DARPA Robotics Challenge. But this robot is not just a participant, but the winner of this competition. The South Korean team KASTE, which created the DRC Hubo robot, will take home the $2 million grand prize as the winner of the DARPA Robotics Challenge. This robot did the best job of navigating the obstacle course. But far more important than the money is the feeling of triumph, winning the prestigious DARPA competition, which lasted more than 2 years. The Pentagon announced the competition back in early 2013, after which there were 2 preliminary rounds of competition. During the 2 days of the final competition, each robot was given 2 attempts to complete an obstacle course that included 8 challenges. Of the 24 participating robots, 12 were from the United States, 5 from Japan, 3 from South Korea, 2 from Germany, and 1 each from Italy and Hong Kong. But the win went to South Korea's Hubo robot, which particularly impressed with its ability to work on its knees. It has special wheels on its knees, so the robot can even drive in the desired direction. Hubo has been in development since 2002 and weighs 80 kilograms at a height of 180 centimeters. Sensors and software allow it to form a 3-dimensional map of the terrain and recognize objects. For the competition version of DRC Hubo, the developers completely remade the walking algorithm and made the robot more stable. DRC Hubo can reach objects above it while maintaining its balance. The upper part of the robot rotates 180 degrees, while the lower part stays in place. It took Hubo 44 minutes to complete all the tasks. During this time, he managed to score a maximum of 8 points. South Korea began presentations of new unmanned ground vehicles developed by the local industry, unveiling the unmanned transporter Ariane Smet at a US military base near Seoul. Ariane Smet is a compact unmanned transporter measuring about 3 meters in length and 1.5 meters in width, performing tasks typical of unmanned vehicles of this type. The main features of the Korean transporter include a range of at least 100 kilometers, with the manufacturer claiming it may go even further depending on external factors. The maximum speed ranges from 34 kilometers per hour to 43 kilometers per hour, depending on the type of terrain it travels. The payload capacity is 550 kilograms. The Hanwha Aerospace project aims for Ariane to transport wounded personnel and military cargo, such as ammunition, medical supplies, consumables, and more. Developers have designed it for tasks like reconnaissance, surveillance, as well as remote search operations. Flying and walking drones may no longer surprise anyone. However, the United States Marine Corps is currently working on creating a drone capable of moving both on water and on rough terrain. GuardBot is a unique robotic system designed for comprehensive surveillance and detection of improvised explosive devices. It features a sealed spherical construction housing observation cameras and sensors. Last year, the drone underwent testing in water and on land, where it was deployed into a water body, executed planned movements on both water and land, and returned. GuardBot has a movement speed of approximately 6.5 kilometers per hour on water and up to 35 kilometers per hour on land, with a surface incline of no more than 30 degrees. Inside the drone, stabilization mechanisms and a movement system are located, shifting the drone forward by moving the center of gravity back and forth. The sphere is powered by reliable Eagle Peacher batteries and can operate for up to 18 hours without recharging. GuardBot operates in two modes: remote, where it can be controlled by an operator, and autonomous. It moves almost silently and can wait for a command to execute a task for some time. A mobile sensory platform, GuardBot is designed for covert surveillance, providing remote inspection and identification of various objects, including chemical substances, using an onboard combination laser. It can also be used as an observation robot, explosive substance detector, and a transportation vehicle for carrying bombs. This is the joint development of NASA and DARPA's, the RoboSimian Spider robot. RoboSimian, a robot designed to work in challenging environments, has 4 limbs with multiple joints. The robot was also developed as part of the Robotics Challenge competition organized by DARPA. RoboSimian can easily overcome various obstacles and even open doors. In the first stage of the DARPA Robotics Challenge, in which 16 teams participated, RoboSimian took 5th place and reached the finals. The robot is capable of removing debris, climbing ladders, and working with construction tools. All of this can help in disaster relief, particularly in situations where people's work involves lethal risks. The developers have equipped RoboSimian with 4 robotic arms, with each limb segmented. At the end is a manipulator with several degrees of freedom. This manipulator can rotate, bend, as well as grasp objects and even work with construction tools. Among other skills, it is able to climb ladders, for which the shape of its body and overall design are just perfect. The robot can perform some movements autonomously, but it is designed for remote work. In the future, this robot can be used both in the military needs of the US Army and in NASA space programs. In late October 2022 in China, a robotized dog with a machine gun was unveiled, which can be transported via a drone. In the video, a robotic dog is dropped from a drone onto the roof of a building. After the UAV departs, the robot dog, equipped with a mounted machine gun on its back, stands up and begins to survey the landing area for potential threats. Such drones can be used for attacking vulnerable enemy positions in the rear or for occupying rooftops, enabling a 3-dimensional assault. The weapon employed by the robot dog is the lightweight Chinese machine gun QBB-97. The QBB-97 is capable of firing up to 650 rounds per minute at an effective range of up to 400 meters. The weapon is designed in a bullpup configuration and uses the new Chinese 5.8mm intermediate cartridge in its base version. Combat robots encompass not only anthropomorphic devices that partially or fully replace humans, but also those operating in the air and water environments. As of October 2022, the majority of combat robots are telepresence devices, with very few models having the capability to perform some tasks autonomously without operator intervention. The new combat robots of the Chinese Army are adapted to various terrains and can substitute soldiers in particularly hazardous missions. An increasing number of warrior robots are being incorporated into the arsenal of the Chinese armed forces. At the IDEF exhibition, the Chinese company Xi'an showcased its helicopter-type drone bomber Blowfish A2 and its new development, the helicopter-type strike UAV Blowfish A3. The drone can be equipped with air-to-ground missiles with radar guidance or precision-guided bombs with laser guidance weighing 6 kilograms, along with machine gun weaponry. This electrically powered drone operates silently, making it ideal for reconnaissance missions and stealthy approaches to the enemy beyond radar detection. Blowfish A2 can be launched with a single button press and is fully capable of autonomously executing complex combat tasks, including fixed-range reconnaissance, precision strikes, and more. Xi'an is also developing a new unmanned helicopter, the Blowfish A3, with a length of 2 meters and a width of 0.5 meters. The Blowfish A3 drone can be armed with a machine gun or a 40mm grenade launcher. The detachable tail structure of the helicopter UAV makes transportation and storage highly convenient. It can take off and land in a small area, making it perfect for operations in confined spaces, such as ship decks. With a payload capacity of 15 kilograms, it is designed for various payloads. It can be equipped with an artificial vision module for automatic target detection and trajectory planning. One of the most powerful ground-based drones in the world is the Uran 9. In terms of firepower, the unmanned combat vehicle Uran-9 holds the top position globally. The Russian military robot visually resembles an infantry fighting vehicle, measuring approximately 4.5 meters in length and 2 meters in width, with a total combat weight reaching 10 tons. The robot is equipped with a 30mm automatic Cannon 2A72, paired with a 7.62mm machine gun. Launchers with 4 9M120 Ataka anti-tank missiles are installed on both sides of the turret. These can be replaced with Igla anti-aircraft missiles if needed, providing air defense capabilities. 6 reactive flamethrower Shmel are positioned at the rear of the turret. Currently, there is no unmanned combat vehicle in the West that can match the firepower of the Uran-9. Importantly, this combat robot has already participated in real combat operations in Syria, where, according to the developers, it demonstrated its effectiveness. Details of the Uran-9 application in the Syrian conflict are unknown, but the machine's testing in a combat environment revealed several issues inherent to such technology. While the United States, the United Kingdom, France, and other countries are actively developing combat robots to reduce human casualties on the battlefield, Russia had faced some technological lag in this field. However, the introduction of the Uran-9 has significantly reduced this technological gap. Vision 60 by Ghost Robotics is a mid-sized, high-endurance, four-legged robot intended for use in defense, homeland, and enterprise applications. The robot is agile and durable enough to survive all-weather conditions in a wide range of environments. The Ghost Robotics V60 UGV has a rugged design, which enables it to quickly adapt to new environments using a blind mode control core. The legs and arms of the system can be interchanged. The UGV weighs 51 kilograms and can carry payloads weighing up to 10 kilograms. The system can be assembled and disassembled within 15 minutes. The V60 is controlled by an operator using a control pad, which looks like a gaming controller. The robot can walk at up to 3 meters per second and run for 3 hours, or travel 10 kilometers on a single charge. Cameras are fitted on the front, rear, and sides, offering 360-degree views and enhancing the situational awareness, which is important for users to plan effective strategies. Here is Chimp, the first rescue robot tank. He was developed by a team from Carnegie Mellon University for the same Pentagon's DARPA Robotics Challenge. The robot has the following dimensions: 145 centimeters in height, 69 centimeters in width, and 25.4 centimeters in thickness. Its weight is almost 200 kilograms. Chimp can operate both in autonomous mode and under human control. 6 video cameras and the LiDAR module, an active optical rangefinder, provide the operator with a full 360-degree view. The robot's shoulders are slightly angled forward, a design that allows the robot to squeeze through narrow doorways. Despite its humanoid lower limbs, Chimp does not walk, but rolls around on rubberized tracks like a tank. This reduces the risk of tipping over. However, in difficult conditions, the robot can get down on all fours for greater stability. With its computer vision, Chimp is able to independently determine the purpose of an object or tool, and then use it as intended thanks to motion planning algorithms. Chimp is also statically stable, meaning the robot doesn't need to expend energy to balance itself. It also locks articulations that are not engaged in the task. Another giant combat transformer robot created in Japan, with potential military applications in the future, is Arcax. Arcax is a piloted humanoid robot that can transform into different modes. The mech robot Arcax stands at a height of 4.5 meters, and its weight reaches around 3.5 tons. The robot features a control cockpit, 4 legs, each equipped with a wheel to aid in movement. Moreover, it can transform. By pressing a button, the pilot can easily expand or contract the platform's wheelbase. The actual mechanism is made from an alloy of iron and aluminum, while the outer shell is crafted from fiber-reinforced plastic. The robot can be controlled using 2 joysticks, 3 large monitors, and various pedals inside the cockpit, equipped with a total of 26 cameras for navigation. It is reported that in a standing position, Arcax can reach a maximum speed of 2 kilometers per hour, while with the wheelbase extended, it can achieve speeds of up to 10 kilometers per hour. The mechanism is equipped with functional arms with articulated fingers that the pilot can use to lift objects weighing up to 15 kilograms. It is worth noting that Arcax has been tested by Japanese regulators, who deemed the system safe enough for potential buyers, and the robot is available for purchase at a price of $2.7 million. Raytheon has demonstrated its second-generation XOS-2 exoskeleton. According to the creators, the exoskeleton transforms an ordinary soldier into a superhero, endowing them with exceptional superhuman abilities. The suit significantly accelerates and simplifies the activities of soldiers. One soldier in the exoskeleton can perform the work of at least 2 or 3 soldiers without it. The exosuit is highly mobile and does not restrict the movements of the person wearing it. It allows for activities like playing football, climbing stairs, and accommodating additional armor and weaponry that were previously only installed on lightly armored vehicles. The only drawback is its power source, a lithium-ion battery, which currently lasts only for 4 hours of operation, which may be insufficient for a forced march or real combat. Research and development of exoskeletons and robots are actively ongoing worldwide, and in the near future, they are expected to significantly enhance our physical capabilities. The hope remains that scientists will not delay their development for too long. The armored tracked vehicle Soratnik is designed for reconnaissance and relay, patrolling, guarding territories and important objects, demining, and delineation. This robot operates in 3 control modes: manual, automatic, and direct control. The complex weighs no more than 7 tons and can reach speeds of up to 40 kilometers per hour. With remote control and direct visibility, the machine has an operational radius of up to 10 kilometers. The armored robot can also be used as a fire support vehicle, transporting ammunition and fuel, evacuating the wounded, and providing guard duty. It has an armored hull capable of withstanding gunfire up to 7.62 millimeters caliber. The robot is equipped with interchangeable combat modules, which can be armed with 7.62 and 12.7 millimeter machine guns, various types of grenade launchers, and Cornet anti-tank missile. There is also the option of installing a high-speed 30mm cannon and anti-aircraft missiles. At the Army 2022 Arms Exhibition in Moscow, an advanced Russian development was shown, a robot dog armed with a grenade launcher. The design, resembling a dog, belongs to the Russian company Intellect Machine, specializing in robotics, weaponry, and artificial intelligence. According to the developers, the robot dog is capable of accurate shooting and weapon transportation. In civilian applications, it can be used in emergency situations for reconnaissance, navigating through debris, and delivering medical supplies. In combat scenarios, the robot dog can also engage in target designation, patrolling, and security tasks. However, the US believes that the Russian robot dog with a grenade launcher is a copy of a Chinese counterpart. The dog closely resembles the Unitree Yushu technology dog from Unitree Robotics, available for purchase at $2,700 in online stores. The M81 is draped with fabric to conceal its origin. The assertion in a publication suggests it seems entirely obvious that the robot was not developed by a Russian manufacturer. Share your thoughts in the comments about this Russian development. Big Dog is a quadruped robot developed by Boston Dynamics. This robot represents an advanced solution in the field of robotics and was created for carrying loads and traversing challenging uneven terrains. An important characteristic of Big Dog is its ability to maintain stability during movement, thanks to dynamic stabilization. The robot has an impressive payload capacity, making it valuable in situations requiring transportation of equipment or materials in hard-to-reach places. Big Dog is equipped with a system of flexible and powerful legs, enabling it to overcome obstacles like rocks or snow. This robot can move at a considerable speed and is equipped with sensors and cameras for environmental perception. Approximately 50 sensors are located on Big Dog. These measure the attitude and acceleration of the body, motion, and force of joint actuators, as well as engine speed, temperature, and hydraulic pressure inside the robot's internal engine. Low-level control, such as position and force of the joints, and high-level control, such as velocity and altitude during locomotion, are both controlled through the onboard computer. China is developing its first mass-produced humanoid robot with artificial intelligence, intended for military applications. Fourier Intelligence, a Chinese company, unveiled the humanoid robot GR1 at the World Artificial Intelligence Conference in Shanghai in late July of last year. The company plans to commence mass production of the robot in 2024 and release thousands of units into the market, including for military applications. The humanoid robot GR1 can move on 2 legs at a speed of 5 kilometers per hour and carry a payload of up to 50 kilograms. Development work on the robot started in 2019, and by 2022, the developers successfully enabled the robot to stand on 2 legs and walk. Fourier Intelligence's humanoid robots can be used not only for military purposes, but also for caring for the elderly, educational purposes, and hospitality. Experts interviewed by SCMP noted that companies developing humanoid robots face challenges in consumer market implementation. Such robots are mainly used in laboratories and can cost millions of yuan. The Russian Venom Term Crawler robot is a compact and universal machine that can be used to showcase products in a unique and interactive way. This robot was created as an illustration rather than a real combat robot. However, the Russian military did become interested in it and started using it to demonstrate what the modernized robots in the Russian army can do. Equipped with advanced technology, it can move freely, demonstrating the features and benefits of the product in an attractive and entertaining manner. The Venom Term robot is also used by not linked with Department of Defense advertising companies. It can be programmed to display products and messages in creative and attractive ways. For example, it can be equipped with a large screen to display product features, benefits, and key features, or programmed to perform a series of movements that emphasize key product features. In addition to its unique capabilities, companies can choose the color, design, and graphics that match their brand image and message, making it a powerful tool for brand recognition and promotion. Who knows, perhaps real development is now underway based on this universal and unusual Venom-term robot, and we may see an army of similar killing machines in the near future. Engineers at Rheinmetall have tested the latest combat robot, Mission Master SP. The autonomous platform was directed through challenging terrain for several days to assess its battlefield capabilities. Developers and military representatives from 20 European countries who attended the tests were satisfied with the capabilities of the robotic platform. The Mission Master SP from Rheinmetall is part of the Mission Master series. This robotic platform exists in a primary cargo version, designed for evacuating casualties from the battlefield or remotely delivering ammunition or medical supplies to combat units. However, various combat modules can be installed on the platform, turning the silent partner into a potent weapon capable of engaging enemy vehicles. The vehicle operator collaborates with reconnaissance, which provides enemy coordinates or independently guides missiles to detected targets. Previously, the platform successfully underwent testing with the Rheinmetall Field Ranger multi-remote controlled combat module, equipped with two 7-tube 70mm rocket launchers from Thales with laser guidance. The rockets can engage targets at distances of up to 7 kilometers. While the testing was not a competitive event, military personnel noted the high autonomy, with minimal driver intervention in the system's operation, effective obstacle avoidance technology, high speed, and maneuverability. In Estonia, the latest robot tank called Type X has been developed. The tank is designed to support mechanized units and can accompany main battle tanks. This allows forces to break through enemy defensive positions with minimal risk. Type X can be equipped with cannons or anti-tank missiles, and it can also be joined by a drone for remote reconnaissance. The company notes that the tank provides equal or superior firepower compared to traditional infantry fighting vehicles. It can be used for target localization, engagement, and flank support. Type X significantly enhances troop survivability and reduces the risk of casualties by increasing the standoff distance from enemy units. During recent exercises, the Type X robot tank demonstrated its combat capabilities in engaging vehicles and armored vehicles. As part of the Nordic Robotic Wingman project, the machine was designed by engineers from Milrem Robotics and Kongsberg Defense. They were tasked with creating a combat robot that meets the requirements of NATO and Northern European countries. Exoskeleton technologies can provide new capabilities to military forces and enhance endurance and safety in industrial settings. Lockheed Martin continues to refine next-generation industrial products with a primary focus on electrically powered exoskeletons. The new Lockheed Martin exoskeleton called Onyx for the lower body has demonstrated its ability to enhance mobility and reduce user fatigue. By reducing efforts during walking and climbing, this technology can significantly assist soldiers and rapid response services in carrying the necessary mission equipment. Onyx conforms to the human body. Sensors located on the exoskeleton communicate speed, direction, and angle of movement to the onboard computer, which activates electromechanical actuators in the knees. The exoskeleton provides the necessary torque at the right time to aid in bending and straightening the knee. Ultimately, Onyx reduces the energy required for traversing terrain, squatting, or kneeling. These benefits are most noticeable when ascending or descending stairs or moving on inclined surfaces. American company Sarcos Robotics has unveiled its powerful exoskeleton, the Guardian XO, which allows for effortlessly carrying heavy loads weighing up to 90 kilograms. Meanwhile, the operator feels like they are carrying no more than 5 kilograms. The US military quickly expressed interest in the exoskeleton, as such technology could significantly enhance a soldier's effectiveness on the battlefield. The Sarcos Guardian XO is a robotic exoskeleton with 24 degrees of freedom and a walking speed of 1.3 meters per second. The system is equipped with a battery with a runtime of about 2 hours. When the battery is depleted, it can be quickly replaced. According to the manufacturer, it takes just seconds to put on and activate the exoskeleton, and learning to use the system requires only a few minutes. The Guardian XO is a robot that uses a real person as its control system. Essentially, it is not the operator carrying the exoskeleton, it is the exoskeleton carrying the operator. Therefore, despite the system appearing bulky and weighing around 70 kilograms, the person practically doesn't feel the weight of the robot and the carried load. The American company Harris has developed a new EOD robot, the T7, along with a feedback control system. The robot's control system provides tactile feedback to the operator, aiming to give operators a dexterity similar to that of a human hand when controlling the robot manipulator through the remote control joystick. The T7 is compatible with standard EOD equipment and weaponry. Harris's unmanned ground vehicle is equipped with high-resolution cameras, lightning-fast data transmission channels, an adjustable manipulator, and robust all-terrain tracks, allowing it to neutralize a wide range of explosive threats. The T7 interface ensures user-friendly operation for operators, offering unparalleled control and monitoring capabilities. Its control precision and maneuverability reduce task completion time, enhancing mission efficiency, while the robust track system provides exceptional mobility and maneuverability needed for challenging terrains. In case the manipulator encounters or hits an object, the operator feels it through vibrations and increasing resistance on the robot control joystick. This robot was developed by the American company Vecna Technologies to rescue soldiers wounded in combat zones. However, this robot can be used not only for military purposes. The robot can not only lift a significant weight of up to 270 kilograms, but also tirelessly carry it over long distances using high-powered hydraulic drives. The robot's high mobility is also noteworthy, as 2 pairs of tracks help it overcome various obstacles in its path. The initial versions of the Bear were remotely controlled by a human operator who was able to see and hear through the robot's sensors. Developments to the Bear's artificial intelligence have given the robot the ability to process higher-level commands given by an operator, such as go to this location or pick up that box. If the robot is unable to execute the operator's command, it asks the operator for assistance to complete a task. The latest version of the Bear robot has infrared, night vision, and optical cameras, as well as a microphone. The U.S. Army has procured 350 new FLIR Cobra robotic systems under the CRSH program at a total cost of $110 million. Developed by Endeavor Robotics, the multifunctional FLIR Cobra robotic system is a remotely operated tracked platform weighing 166.4 kilograms with electric propulsion, capable of moving payloads up to 150 kilograms. It has a maximum speed of 8 miles per hour and a runtime of up to 10 hours. The robot is equipped with multiple high-definition cameras, a manipulator weighing 60 kilograms, and a remote control system with claimed enhanced cybersecurity and interference protection. The robot is suitable for missions such as explosive detection, explosive ordnance disposal, bomb disposal, persistent observation, and checkpoint or vehicle inspections. It can also be used to detect and identify chemical, biological, radiological, and nuclear materials from a standoff distance. In front of you is the TRX SHORAD robotic tank, which is positioned as a drone killer. TRX is the designation for the category of 10-ton tracked robots developed by General Dynamics, a platform capable of carrying various payloads, including cargo and weapons. SHORAD stands for Short Range Air Defense, a military acronym encompassing the search and destruction of threats such as drones, helicopters, low-flying aircraft, and more. The TRX is designed to bring a new dimension of combat power to SHORAD battalions and provide autonomy in a multi-layered air defense environment. The robot tank offers multi-layered protection, featuring onboard ammunition for destroying small drones, projectiles for larger and faster threats, and sensors for detecting and tracking aircraft movements. TRX can accompany soldiers, trucks, armored vehicles, and heavier equipment like tanks, offering an additional line of defense in modern warfare. The main feature of these machines is the ability to autonomously navigate and engage enemy targets without the intervention of operators of robotic systems. Military robots are being developed at the Korean Institute of Industrial Technology, aiming to replicate the mobility, stability, and endurance of the Boston Dynamics Big Dog robot. This robot is powered by hydraulic actuators and is designed to navigate to specified coordinates, autonomously assess the terrain, and adjust its gait accordingly. Additionally, the Institute is working on a robot tank capable of serving as border patrol, reconnaissance, and security personnel in unmanned mode. The robot is equipped with cameras, a microphone, and a speaker for communication and identity verification of potential intruders. It can also be equipped with a machine gun and a wide range of other weapons. The robot tank reaches speeds of up to 50 kilometers per hour and can cover 20 to 30 kilometers in a shift, depending on the complexity of road conditions. Interestingly, all 6 wheels of the robot can rotate 360 degrees. There are real-world examples of artificial intelligence being used for military purposes. The northern borders of South Korea are guarded by SGR-A1 sentry robots, automated machine gun towers developed by Samsung and controlled by artificial intelligence. This system is considered the first of its kind, integrating observation, tracking, shooting, and voice recognition capabilities. British company Gravity Industries continues to test its JetSuit jetpack. In 2022, Gravity Industries tested the jetpack in NATO search and rescue exercises in the forests of Slovenia. During the exercises, the company's founder, Richard Browning, flew along a mountain trail and delivered a blood plasma to a soldier in a ravine, simulating a wounded man. The jet suit is equipped with 5 gas turbine engines with a total power of 1,050 horsepower and a thrust of 144 kilograms. The jet suit can cover a distance of 5 kilometers in 3 to 4 minutes. The suit allows speeds of up to 137 kilometers per hour and can lift the pilot to an altitude of up to 3,500 meters. According to Browning, the suit is suitable for various terrains. He flew along a mountain trail between trees. Gravity Industries founder believes that this feature of the design can be useful in emergency situations in hard-to-reach places, such as mountains, gorges, and forests. Gravity Industries introduced the jetpack in 2017, and it is available for purchase at $438,000. In 2021, the British Royal Marines, in collaboration with Gravity Industries, tested the use of the jetpack for military personnel to board a ship from boats. Engineers from the Korea Advanced Institute of Science and Technology, in collaboration with Rainbow Robotics, have developed the mobile humanoid robot FX2. When it comes to piloted humanoid robots, it is usually implied that the pilot will be in a cabin at a sufficiently high height. Korean engineers took a different approach in their development, opting for an open-seat design. Instead of a closed cabin, the mobile humanoid robot FX2 is equipped with a pilot seat that is not enclosed by a safety frame. Apparently, the developers decided that due to the low height of the seat, which is less than 2 meters above the ground, a helmet would be sufficient. At the moment, FX2 is unlikely to serve as a fully fledged, widely used means of transportation. However, as shown in the video, it is capable of moving together with a person sitting in it. The robot also has 2 arms with a degree of freedom comparable to human arms, featuring joints in the shoulders, elbows, and wrists, as well as all the phalanges on the 5 fingers of each hand. The pilot controls both the robot's movement and the manipulators using 2 joysticks, including the movement of individual fingers of the robot's hands. The combat robot Marker is a robotic platform that resembles a small tracked robot. The developer boasted that Marker can now travel 1,000 kilometers, carry loads, and evacuate the wounded. The robots are designed for military operations not only on the battlefield, but also in urban areas. They have been tested both in exercises and actual combat, where they performed well. Marker can be used either as a remote-controlled machine or carry out some functions autonomously. According to the developers, the combat platform can operate in autonomous mode, consuming 30.5 liters per hour, sufficient for a 1,000-kilometer cross-country journey or 50 hours of autonomous operation. The robot's developers also claim that Marker can be used for automatic delivery and unloading of cargo. Additionally, with the help of a hydraulic manipulator, the system is capable of autonomously extracting cargo containers from storage. Saphir, shipboard autonomous firefighting robot, is a remotely operated android developed for the United States Office of Naval Research. Standing at 178 centimeters tall and weighing 65 kilograms, approximately 143 pounds, Saphir is designed for firefighting on ships using a fire hose under real-world conditions, such as uneven surfaces or smoke-filled environments. The choice of a humanoid robot was made due to the challenging conditions it may encounter on the ship's deck and interior. Narrow corridors, hatches, and stairs make it impractical to use a wheeled robot carrying water or fire extinguishers. Currently, Saphir has modest capabilities. Vision through smoke is provided by a pair of infrared cameras and a LiDAR sensor, and it receives action commands from the operator's console. The engineers plan to achieve full autonomy for Saphir, completely relieving the ship's crew from firefighting duties. The combat robot Nerecta is a group of robotic systems united under a single control system subordinate to a human operator. The operator has the choice to stay behind and control remotely, or be with the robot on the front line to execute tasks. The robotic platform with a combat module is operated from a command post, which can be located anywhere, even in a separate armored vehicle or at a stationary point. Before the battle, the map of the area and grids of key landmarks to be eliminated are loaded into it. In combat, special forces do not need to control every movement of the teletank. It is sufficient to press a button and select one of several tasks. The Nerecta combat robot, as a platform, is designed for reconnaissance operations, adjusting fire on enemy positions, and the rapid delivery of ammunition and supplies to hotspots. The Russian robotic complex Platform M is a remotely controlled robot on a tracked chassis. It is an armored robot, remotely operated, armed with a grenade launcher and machine gun system for engaging in combat without direct contact with the enemy. According to the developers, the complex is designed for reconnaissance, detection, and engagement of stationary and moving targets, providing fire support for units, as well as for patrolling and guarding important objects. The latest combat complex includes means of differentiated armor for the chassis and weapon platform. The complex can enable conducting combat operations at night without revealing factors. German company Mailer Protection, in collaboration with Canadian experts from Mawashi Science and Technology, has created a true masterpiece for the French gendarmerie, the bulletproof tactical exoskeleton EXOM. The armor plates enveloping EXOM comply with protection class VPAM-8, according to the European standard. This means it can withstand 3 hits from an AK-47 rifle at a distance of 10 meters, with the steel plates measuring a robust 12.5 millimeters in thickness. However, the strength of the suit is not its only important feature. The titanium frame of this exoskeleton redistributes around 70% of the load from the wearer's shoulders. Notably, EXOM is a passive exoskeleton, meaning it operates without a motor. This implies no concerns about heavy and cumbersome batteries that could run out at the most inconvenient moment.